Moment of inertia of a uniform linear mass. Objective: to find moment of inertia of a uniform linear mass. Consider a uniform straight rod of mass m and length L. Let us find the moment of inertia of the rod L about an axis perpendicular to the rod and passing through its center. Consider the center of the rod as the origin and that the x-axis lies along the length of the rod. The rod can be considered as the collection of infinitely small elements extending from minus L by 2 to plus L by 2. Consider an element of length dx at position x from the origin. As the rod is uniform, the mass of the small element dm is equal to mass of the rod m divided by length of the rod L multiplied by length of the element dx. Moment of inertia at a point of mass about an axis is the point of its mass and square of its distance perpendicular to the axis of rotation. Hence, the moment of inertia of this elemental mass di is dm into x square. The rod is a continuous mass extending from minus L by 2 to plus L by 2. So, moment of inertia of the total rod is equal to the sum of the moment of inertia of all such elemental masses, which is nothing but integral of dm x square from minus L by 2 to L by 2. Substituting for dm and taking the constant terms out of integral, we have I equal to m by L integral x square dx from minus L by 2 to L by 2. On integrating and substituting the limits, we get I is equal to ml square by 12. If the axis of rotation is about an axis perpendicular to the rod and passing through one of the endpoints, the integrand from the previous result remains the same, whereas the limit varies from 0 to L. On integrating and substituting the limits, we get the moment of inertia about an axis passing through the endpoint as ml square by 3. Summary: the moment of inertia of a uniform linear mass about an axis perpendicular to it and passing through its center is ml square by 12. The moment of inertia of a uniform linear mass about an axis perpendicular to it and passing through one of its endpoints is ml square by 3.